Welcome to this comprehensive guide on C# programming, where we'll demystify two fundamental concepts: method overloading and method overriding. These powerful features are cornerstones of object-oriented programming, enabling you to write more flexible, readable, and maintainable code. Understanding them is essential for any aspiring C# developer looking to build robust applications. Understanding these concepts is crucial for writing flexible and maintainable code, especially as you delve deeper into object-oriented programming principles. They allow you to design systems that are adaptable to change and easy for other developers to understand and extend, which is a hallmark of professional software development. Let's begin by exploring method overloading, often referred to as compile-time polymorphism. This concept allows you to define multiple methods within the same class that share an identical name but are distinguished by their unique parameter lists. The compiler then intelligently selects the appropriate method based on the arguments provided during the method call. Method overloading allows a class to have multiple methods with the same name but different parameter lists. This means you can have several versions of a method, each designed to handle different types or numbers of input arguments, all while maintaining a consistent and intuitive naming convention for related operations. The compiler determines which method to call based on the number, type, and order of arguments passed during the method invocation. This decision is made at compile time, before the program even runs, which is why it's known as compile-time polymorphism. It ensures that the correct method signature is matched precisely to your function call. Consider a simple example: a calculate method that can add two integers or concatenate two strings. You might define one calculate method that accepts two int parameters and another calculate method that takes two string parameters. Both perform a calculation, but on different data types. Both methods are named calculate, but their parameter types differentiate them. The C# compiler uses these distinct parameter signatures, whether it's two integers or two strings, to determine which specific calculate method implementation to execute when your code is compiled. This flexibility makes your code more readable and intuitive, as you can use a single, descriptive name for related operations. Instead of needing unique names like add integers and concatenate strings, you can simply use calculate, making your code cleaner and easier to understand at a glance. A helpful tip for overloading is to ensure that the overloaded methods perform similar logical operations. While their input types may differ, their core purpose should remain consistent. For instance, a print method could print various data types, but all versions should ultimately handle output. This maintains consistency and prevents confusion for other developers reading your code. When methods with the same name perform vastly different, unrelated tasks, it can lead to unexpected behavior and make the codebase harder to navigate and maintain in the long run. Now, let's shift our focus to method overriding, which is a core concept of runtime polymorphism. Unlike overloading, overriding deals with methods in an inheritance hierarchy, allowing derived classes to provide their own specific implementations for methods defined in their base classes. Method overriding allows a subclass to provide a specific implementation for a method that is already defined in its superclass. This means a child class can change the behavior of an inherited method, tailoring it to its own unique requirements while still adhering to the base class's contract. This is crucial for achieving polymorphism, where objects of different classes can be treated as objects of a common base class. You can write code that interacts with a base type, and at runtime, the specific implementation of the derived object will be automatically invoked, leading to highly flexible designs. To enable overriding, the method in the base class must be declared with the virtual keyword. This keyword explicitly signals to any derived classes that this particular method is designed to be potentially overridden, granting them permission to provide their own specialized version. This signals that the method can be redefined by derived classes. The virtual keyword acts as a contract, indicating that while the base class provides a default implementation, subclasses are welcome and expected to customize or completely replace that behavior if needed. In the derived class, the method must be declared with the override keyword. This keyword is mandatory and explicitly states your intention to replace the base class's virtual method with a new, specific implementation tailored to the derived class's functionality. This explicitly states that the method is providing a new implementation for a virtual method inherited from its base class. The override keyword ensures that the compiler verifies the method signature matches the base class's virtual method, preventing accidental hiding and promoting clear intent. For instance, a shape-based class might have a draw method marked virtual. This draw method in the shape class would provide a generic or default way to draw a shape, perhaps just outlining its boundaries, but it's designed to be specialized. A circle subclass would then override the draw method to implement drawing a circle. Similarly, a square subclass would override draw to implement drawing a square, each providing its unique graphical representation while sharing the common draw method name. A key benefit of overriding is that it allows you to write generic code that operates on base class objects. You can create a collection of shape objects, which might contain circle S, square S, and triangle S, and then iterate through them, calling draw on each. At runtime, the correct overridden method for the actual object type will be invoked, even though you're calling draw on a shape reference. If the underlying object is a circle, the circle sDraw method will execute, demonstrating dynamic dispatch. This dynamic dispatch is what makes runtime polymorphism so powerful. It allows your program to adapt its behavior based on the actual type of an object at runtime, leading to highly extensible and flexible architectures where new types can be added without modifying existing code. Now, let's discuss the new keyword in the context of methods, which often causes confusion when compared to override. The new keyword offers a different mechanism for handling methods with identical signatures in an inheritance hierarchy. When a derived class defines a method with the same name as a base class method, but without using virtual or override, you can use the new keyword. This explicitly tells the compiler that you intend to create a new, independent method in the derived class, rather than overriding the base method. The new keyword explicitly hides the inherited base class method. This means that the derived class's method effectively shadows the base class's method when accessed through the derived type, making the base method less directly visible. This is known as method hiding, not overriding. It's a crucial distinction because method hiding does not achieve polymorphism. It simply creates a new method that happens to have the same name as an inherited one, without altering the base class's behavior. When you call a method on an object declared as the base type, the base class method will be invoked, even if the derived class has a new method with the same signature. This is because the compiler resolves the method call based on the declared type, not the actual runtime type, in the case of method hiding. However, if the object is declared as the derived type, the new method in the derived class will be called. This behavior highlights that the choice of method depends entirely on the declared type of the variable rather than the object's actual runtime type, which is different from overriding. A helpful tip: use new sparingly and with caution. While it has its niche uses, relying heavily on method hiding can often lead to less intuitive code and potential misunderstandings about which method will be executed in various scenarios. It can lead to confusion and unexpected behavior if not fully understood, especially in complex inheritance hierarchies. Developers might mistakenly assume polymorphic behavior, only to find that the base class method is being called when they expected the derived class's new method. Prefer override for polymorphic behavior, as it clearly indicates an intentional replacement of base class functionality. The override keyword provides a strong, explicit contract for extending and modifying behavior within an inheritance chain, making your code more predictable and robust. Let's summarize the key differences between overloading and overriding to solidify our understanding. These two concepts, while both dealing with methods of the same name, serve distinct purposes and operate at different stages of your program's execution. Overloading involves methods with the same name but different signatures within the same class, resolved at compile time. The compiler uses the number, type, and order of parameters to select the correct method before the program even begins to run. Overriding involves methods with the same name and signature in a base and derived class, resolved at runtime. This mechanism allows a derived class to provide its own specific implementation for a method inherited from its base class, enabling dynamic behavior. The virtual keyword enables overriding by marking a base class method as replaceable. The override keyword performs the actual replacement in the derived class, explicitly stating the intent to modify behavior. And new hides inherited methods, creating a separate, distinct method in the derived class. Mastering these concepts will significantly enhance your ability to design robust and extensible C# applications. By effectively utilizing overloading and overriding, you can create software that is not only powerful and efficient, but also easy to maintain, adapt, and scale over time. Keep practicing with examples, and you'll soon find these powerful tools indispensable in your programming journey. Experiment with different scenarios, build small projects, and observe how these concepts influence your code's behavior and design. Thank you for joining us in this exploration of C# method overloading and overriding. We hope this guide has provided you with a clear and comprehensive understanding of these fundamental object-oriented programming principles. Continue your learning and happy coding!